Now that we have looked at the game, let's take a look at the code to show how this works. Menus are pretty much handled the same way as I handled tic-tac-toe, so I'll mainly go over the differences. Right here we have screen density, general value I use to size fonts and such, so that on, say, the lower density devices or larger density devices, things aren't out of scale. So right here I use screen DPI, and then I divide by 160, which in Android is the standard DPI size for medium density devices. One problem with just using that is on PCs and Macs and such, DPI is 0. So as an alternative, I use the resolution height in those cases. 600 is probably a bit low. You could probably go higher to make it look a little better, but that's just what I used, based off of an 800 by 600 screen. Another new thing here is alignment. You can see that you can set the alignment for a label. Here I have upper center, so that's how I centered the text for my label here. You see, as I mentioned, everything is relative to each other, and you can see my 3 buttons here: host game, join game, and credits. Server settings. This is what's used in the server settings scene. It sets the room name and level ID initially, and the standard message box and button sizes. The new thing here is the text field, which I have the room name, and I set that to whatever content the text field is set to. So whatever the user types in here will be stored in room name. You can see that it also displays the room name and has a limit of 5 characters. And I do the same thing with player name right here. And then once everything's ready, I have a host button, and that calls validate settings before proceeding. And in validate settings, make sure that the room name is not empty, because empty room names are not allowed. And that causes a pop-up to appear. Now, Unity normally doesn't have message boxes, so this is a good way to fake it. Basically, you have a boolean that determines if it opens up or not. Then have a box. I have this at the bottom of onGUI so that it displays above everything else. This box has the message, then if the button is clicked, the boolean is set to false again and makes the message box go away. Now onto the lobby. You'll see here that I make better use of the space for landscape orientation. In landscape orientation, room buttons to join rooms will appear side by side instead of one at a time to make better use of the horizontal space. So that's what this is for. If we have a host list, that means that we found some servers, so we're going to list them. And in this case, in case there's a lot of servers, I want to make sure there's room for them all, so I use a scroll view. And this is how the scroll view starts. Then I loop through all the hosts and make sure to display each one. Whether I go to the next row or not depends on how many I have. And I base the increase based on that number I showed earlier, whether I'm displaying 1 or 2 in a row. And then if the player decides to join a game, and if the room is not full, then we're going to load the particular level involved. And then we end scroll view here. If we didn't find any servers, then we tell that to the user. And of course we provide a refresh button so that they don't have to leave the scene. They can just refresh. And then you can see more message boxes I created for if the user tried to connect but it timed out, if they were kicked, which currently the only reason they can be kicked is if the game already started, and if the server is full and they cannot join it. And right here we have a master server event. I request the host list for this particular game, and then the master server returns all servers it can find of that game, and I pull that list so I can grab it and store it in my host list variable. Next we have Network Manager. This is in the game itself. First thing we do is we make sure that this runs in the background. Basically, if the user leaves the app for whatever reason, we want this to still run, because otherwise we could have problems with the network. when we first start out, we're not in the room and the game hasn't started. If server data has been set, meaning we've been to server settings, then we are hosting a game and we want to initialize a server. Then with that initialized server, we register it on the master server, so it can be pulled later. And we include our room name to be displayed on the lobby and the level ID. And if we don't have server data, then we're a client and we're going to connect with what we got. Now here in OnGUI, if we are in the room, then we are connected to the network. If the game hasn't started yet, we display different messages depending on if we're the server or the client. If not enough players have joined yet, which is what this is, then we are waiting for more players to join. If there are enough players and we're the server, then the server can start the game. If we're not the server, then we are waiting for the server to start the game. And then this code determines win or loss. If we won, play some fireworks and say that we won. This is because this is called pretty much every frame, so I only want to play the fireworks if they're not playing already. If we're in a losing state, then show that you lose. And if, whether we have started the game or not, if we have not won or lost, then we could lose the connection to the server or our clients, so we want to check for that. If we are not the server or the client, we used to be a client but we lost our connection, so tell that to the user. If we are the server and we have started already, but suddenly we no longer have enough players, then we lost connection to enough clients. This is what happens if we are not in the room and it's trying to connect to the server and we have a calculated timeout, which is later on down. And this is the general code that displays all of this. If we click to start the game, then we send a message to all players that we're starting the game. Otherwise, it's the main menu, so we want to disconnect from the server and return to the main menu, which is level 0. Now, once we are connected to the server has been initialized, and if we didn't have a player name, we're the server, so we're player 1. Then we instantiate ourselves where player 1 normally goes. And then we are now in the room, so in room equals true. Here is game over, which is what is used to determine if the player can still move or not, which is of course the lose and win states. Disconnect, if we are the server or the client, then we are connected and we want to disconnect. Otherwise, we haven't really connected yet. This is just a safety check in case you're not actually connected to the network. On player connected, this gets called when we are the server and a client has connected to us, and this is our new player. If we have started the game, then we don't want any new players, so we're going to kick the new player from the room and give them the reason game has already started. Otherwise, if it hasn't started yet, we let them in and give him an ID. Num players at this point hasn't been incremented yet to account for the new player, so I add 1 here. On player disconnected, this is what happens when people leave. We want to make sure that their player object gets destroyed properly. So in this case, we remove any RPC calls that are pending, and we destroy the player objects. And last, we have our RPC calls. This is, of course, start game. Start game equals true, and for all of our clients, we set the total number of players. This is to determine, essentially, win state increases by 1 for each player that loses, and we want to get to num players -1. So that is why this is passed to everyone. Then we have join room, which of course sets the player name if they haven't set their own. This is originally spawn code. I could not get more than 2 players to work, so currently this is commented out. But after the player is instantiated in his corner, the client, then in-room is true, and we're going to null the server data so that if they return to the lobby, it won't cause problems if they go to host their own game, and it'll think they're a client or something. Here is kick. It disconnects them from the network and lets them know about the message when they return to the lobby, which is level 2. And here we have our update, which is our timeout code. If we are not in the room and we're waiting to join, then timeout keeps increasing. If we reach the limit, kill the server data and then kick us from the room. And then, of course, if the player leaves intentionally by escape, we want to make sure to disconnect and not leave the connection open. Player camera, this is pretty quick. This is just a debug code for acceleration. The accelerometer is pretty easy to implement. It's just input.acceleration plus whatever direction you have. In the case I'm using, you'll see later, I only use X and Z. Here we have attached. This is how the camera follows the player. it just moves to the player's position. Plus it adds a 2.4 because of how it's angled. It needs to offset itself a bit in the southern direction. And then we position ourselves, and then we set the parent of the camera to our player so that it will follow it. And then when we detach, we want to delete that connection. Now for the player, when we are created, if this is our player and not the other person's player, because this is created on both sides, we want to instantiate our name above the player. If network.instantiate, only one person needs to call it, and it will be created for everyone. This is initially positioned at the player, it gets moved later, and has the same rotation as the camera so that it looks correct. And then once we've done that, we make sure to tell everyone to set the player name of the person's player name so that everyone sees the correct name. And we also pass in the ID of our player name so we can grab the object to set the string. And then, of course, afterward, we attach the camera to this player because we know this is our player. Here in Update, we want to make sure this is our player so that we are only controlling our own player instead of all of them. And we also want to make sure the game has started and it's not over. Then once we've done that, we check to see if we're using the accelerometer. If we are, then we set horizontal to the x coordinate plus times some multiplier, and then z plus some offset. The problem was at neutral position, the ball would roll slowly north, so I added an offset to counter that. And then here we get keyboard input or gamepad input, whatever you're using for horizontal or vertical if we're not using the accelerometer. And once we have those, we create a vector for moving, and we add a force to the player times the speed. Here we have on collision enter. This is when we tell if we won the game or not. This is ourselves, and other is the other player we collided with. If we are in a winning situation, which is all these colors that you see here, in this case, if we are anything other than neutral and our opponent is neutral, we still win. Then we send this message to everyone. I send a message instead of just doing it directly because sometimes, because it only transfers over position instead of force over the network, opponents may not collide with each other over the network. So to make sure things stay in sync, I send an RPC instead. Set player name, as I mentioned, it attaches the text to the player. And here, if we are the loser, then we want to say that we lost, and we want to kill the player object. So we detach everything, including camera, player name, and then we destroy the objects so that they're no longer there. Otherwise, we are getting closer to winning because our opponents are dying, so we increase win state by 1. Player name is simple. It's similar to player camera. You just have attach and detach. The difference I use here is I use local position. Local position is position relative to its parent. By doing this, then I just say it's somewhere above the player, which makes it easier to position. And then here we have the paint. I have the 4 different colors here as in enum. And then we have a respawn timer for the actual paint object. And we set the color depending on what material we're using for the paint. And then on collision enter, we check to see if a player touched it. Then that player is going to collect the paint. And we set the respawn timer to 10 seconds. And to actually remove it, I actually just place it below the board, which you can see that I changed Y. That's really all I'm doing. I just put it a set distance below. And then here, based on what paint color we are, we set the material of the player so that he's the right color. And then right here, this is where we check for a respawn timer. If there's a respawn timer, we're counting down. Then once it respawns, we put the object back up. And that's pretty much all the code. It was a big learning experience for me because the network, Unity's network can be iffy sometimes, but I think I did rather well considering this is just pretty much a prototype. Most of this was inspired from Matthew here. A lot of the code was rewritten, but most of it was based off of this tutorial, so I have to thank him for that. And how I use the fireworks you can see from this YouTube video here. If you have any other questions, feel free to leave a comment. Thanks for watching.